My name is John and I'll be your instructor in this Python course. Now this course is the continuation of Python for Beginners course. In case you haven't watched it yet, watch the Python for Beginners course and then continue watching. Now in the Beginners course we covered all the basic concepts in Python. Now in this course we'll cover all the intermediate concepts. So I've done my best to create the best possible Python course for intermediates. And I'll appreciate it if you support my hard work by liking this video and sharing it with others so they can learn as well. And be sure to subscribe to my channel for more tutorials like this. Now let's jump in and get started. In this tutorial, I am going to talk to you guys about comments in Python. We use comments to add notes or comments to our program. Here, I'll add a print statement. Print, Python is my favorite programming language. So up here, let's add a hash sign and type this is a comment. So whatever we type after the hash sign is ignored or not executed. Let me show you. So let's run this program. Look, we only see this message. Python is my favorite programming language. So we can use these comments to explain something about our code, or we can use them as reminders, or we can communicate with other developers reading our code. So we can have multiple comments. All comments must contain a hash. One thing you need to avoid while writing comments is to avoid explaining what your code does. An example of bad comment is print Python is my favorite programming language. So why this is a bad comment? Because it is telling what the code will execute, which is very obvious. The problem with this comment, apart from being repetitive, is that if you change this Python to something else, then the comment becomes outdated. You have to come over here again and update the comment. So, use comments to explain something about your code or add a reminder. In this tutorial, we are going to look at formatted strings in Python. Formatted strings are particularly useful in situations where you want to generate text with your variables. Let me show you. Let me say you have two variables, name and language. Name, let's set it to Guido van Rossum. And language, let's set it to Python. So let's say with these two variables, we want to generate some text like Guido van Rossum created inside the square brackets Python during 1985 to 1990. Say we want this message on the terminal. So we define another variable called year and set it to name plus, and inside the quotations add a space and type created. Then again add a space. Now add a plus sign and inside the quotations add a square bracket. Now add a space. Again add a plus sign and type language. Now again add a plus sign and inside the quotations add a space. Now add a square bracket and again add a space. Now again add a plus sign. Now add quotations and type during 1985 to 1990. So if we print this message and run this program, we see Guido van Rossum created Python is inside the square brackets during 1985 to 1990. While this perfectly works, it is not ideal because as our text gets more complicated, it gets harder to visualize the output. So this is where we use formatted strings. They make it easier for us to visualize the output. So I am going to define another variable, say yr, short for a year, and set it to a formatted string. A formatted string is the one that is prefixed with f. So f quotations. So in between the quotations, we will add the value of the name variable. So we need to add curly braces and then inside the curly braces we type name. Then we add a space and type created. Next we add a space and our square brackets. In between our square brackets we want to display the language. So once again we add curly braces and type language. And finally we type during 1985 to 1990. So this is what we call a formatted string. With these curly brackets we are defining placeholders in our string. And when we run our program, these will be filled with the value of our variables. So here we have two placeholders in our string. One is for the value of the name variable and the other is for the value of the language variable. If we compare the formatted string with the concatenated string, we can easily visualize what the output looks like. Now let's print this on the terminal to make sure we get the same output. So let's print YR. So there you go. Jodo van Rossum created, and inside the square brackets Python, during 1985 to 1990. So to define formatted string, prefix your strings with an F and use curly braces to insert a value into your strings. In this Python tutorial, I will show you some cool things you can do with Python strings. So let's start by defining a variable. Let's call this variable creator and let's set it to Python was created by Jodo van Rossum. Now to calculate the number of characters in this string, we can use a built-in function called len. So print len of creator. Let's run this program. So you can see we have 39 characters in this string. This is particularly useful when you receive input from the user. For example, when you fill a form online, you will notice that each input field will often have a limit. For example, it might have 25 characters for your name. Using this len function, we can impose a limit on the characters in an input field. If the user types more characters than we allow them, we can display an error. The len function is another function built into Python. This is not only limited to counting the number of characters in a string. In the future, when we will use lists, I will show you that we can use this function to count the number of items on the list. We also have functions that are specific only to strings, like we have functions for converting a string to lowercase or uppercase. To access this function, we use a dot operator. Let me show you. First, we type creator, then dot upper. Let's run this program. There you go. We get all the letters in uppercase. Note that this method does not change or modify your original string. It creates a new string and returns it. So print our creator variable right after we call our upper method. We can see that our creator variable still has its original form. So let's run this program one more time. Look, this is our original creator variable. It is not modified. Similar to the upper method, we have a method for converting a string to lowercase. Now let's run our program. So on the second line, you can see all characters are in lowercase. There are times that you want a character or a sequence of characters in a string. In those situations, you can use the find method. So let me call creator.find here. Let me pass a character. Let's say O. This will return the index of the first occurrence of the letter. Let me show you. So let me print the result. We get 4 because the index position of first O is 4. Note that the find method is case sensitive, which means it is sensitive to uppercase and lowercase letters. For example, if we pass an uppercase O here, we get -1 because we don't have any uppercase O in this string. We can also pass a sequence of characters. Let's type created. Let's run this program. We get 11 because the word created starts at index 11. Now we also have a method for replacing characters or sequence of characters, and that is called replace. So let's change this find to replace. Say we want to replace Jodo van Rossum with Jodo. So we simply type creator.replace Jodo van Rossum separated by a comma, and then we type Jodo. So let's run this program. So we get Python was created by Jodo. Again, this method, like the find method, is case sensitive. We can also replace a single character. Let's say we want to replace capital P with capital J. When we run this program, we get Jython was created by Jodo van Rossum. So these are find and replace methods. So the last thing I want to show you in this tutorial is that there are times that you want to check the existence of a character or a sequence of character in your string. In that case, you use an in operator. So let's say you want to know if the string contains created. We can write an expression like this: created in creator. So we are checking to see if created is in variable creator. Now this is an expression that will produce an boolean value like true or false. Now if we print this on the terminal, we should get true. So let's run the program. We get true. Now if I change the lowercase c to capital C and run the program, we get false because we don't have the exact sequence of characters in our string. Now the difference between the find operator and the in operator is that find operator returns the index of the character or sequence of the characters, but in operator returns a boolean value. In this tutorial, we will look at a few useful functions for working with numbers. Let's start by defining a variable x and set it to 5.6. Now, to round this number, we can use the built-in round function. So, we call the round function and give it x, and then print the result. Print round of x. Let's run this program. So we get 6. We have another useful function called abs, which is short for absolute. And this is the absolute function that we have in math. Give it a value and it always returns a positive value, even if the value is negative. Here is an example. Let's call the abs function and let's give it negative 5.6, like this. Print abs of negative 5.6. When we run this program, we should get positive 5.6. Let's go ahead. There you go. So absolute always returns a positive value. Now in Python, we have several mathematical operations. Now if you want to write a program that involves complex mathematical operations, you need to import the math module. A module in Python is a separate file with some reusable code. We use this module to organize our code into different files. In Python, we have the math module for performing several mathematical operations. So let me show you how to use this module. On the top, we type import math, all in lowercase. With this, we can import the math module. Now math is an object like string, so we can access its functions or methods using a dot operator. So if we type math.factorial, we can use this factorial method to get the factorial of a number. So if we pass 5 here and print the result, we should see 120. Alright, so let's run this program. So we get 120. Another method which is a useful method is the sign method. Let's give that a try. The sign of 5. What do you think we will get? So let's run this program. We get negative 0.95. So there are so many functions built into this module, and we don't have time to go through all of them. But let me show you how you can learn about them on your own. Open up your browser and search for Python 3 math module. So here you can see the documentation for this module. Let's have a look. If you scroll down, you can see the list of functions and their explanation. So as an exercise, I encourage you to spend 5 minutes having a look at this documentation. See what functions are there for you in case you need them. In this tutorial, I am going to talk to you guys about nested loops in Python. Using a nested loop in Python means adding a loop inside another loop. With this technique, we can do amazing things. Imagine we want to generate a combination of a and b value. Let's say 1, 2. Now let's say we want to generate a list of combinations like 1, 2, 1, 4 and 1, 6. Next, we will change the value of a and we will use the three values of b, like 3, 2 and 3, 4 and 3, 6. So here you can see we are only using a set of odd numbers for a and only a set of even numbers for b. We can easily generate these values using nested loops. So we start by one loop. Let's say for a in range 1, 8, 2. With this loop, we can generate the values for a. Let's print a. So we get all the odd values from 1 to 7. For each A like 1, we need to generate a B value. So that is where we use a nested loop. So inside this loop, we will add another loop. Instead of printing A, we want to add another loop for B in range 2, 8, 2. Now we can print A and B together. So here we use a formatted string to display the coordinates like this. Print and inside the parenthesis F. Now add quotations. Now inside that again add parenthesis. Now add curly braces and type A. Add a comma. Again add curly braces and type B. Let's run this program and see what we get. So there you go. We have these combinations. 1, 2, 1, 4, 1, 6. And then 3, 2, 3, 4 and 3, 6 and so on. So let me explain exactly how this program gets executed. So in the first iteration of our outer loop, A is 1. Now here we are on the loop 2, which we call an inner loop. In this inner loop, the first iteration B is going to be 2. So we print 1 and 2 on the terminal. So next we again go to the inner loop where B is incremented to 4. But our outer loop remains 1. So that is why we see 1, 4 on the terminal. So again this goes to the second line and this goes on till the inner loop completes. That is when B reaches 6. After the inner loop completes, this line goes back to the line 1. At this point we will be on the second iteration of our outer loop. So A will be 3. Then the control will move to the line 2 or inner loop. At this time our range function is going to generate all the even values from 1 to 8. So this inner loop will be executed 3 times. Then we will go back to our outer loop. So this is how the nested loop gets executed. So here is an exercise for you. But this is going to be a little more challenging. So I don't expect you to do this. But if you do this, wow. So using nested loops, I have written a code to draw a triangle. So let me give you a hint. First of all, we have a variable set to 10. So this variable determines the number of hash we have on each line. So here is a tip for you. Using for loop, you need to iterate over this variable using the range function. In each iteration, you get a number that determines the number of hash to be displayed. If you want to cheat, you can use this number and multiply it with a string containing hash. But that is not what I want you to do. I want you to use an inner loop here to generate a string. So go ahead and spend 5 minutes on this exercise. And by the way, it's a little bit challenging but not extremely difficult. It just requires a little bit of focus. You will see my solution next. So let's define a variable called numbers and set it to 10. In the next line, let's write a for loop for number in range of numbers. So if you want to cheat, you can write code like this. Print hash into number. But I want you to use nested loops. So for number in range numbers, in the next line, let's define a variable called triangle and set it to a empty string. In the next line, let's write a inner loop for count in range of number. In the next line, type triangle equals triangle plus hash. Here we are concatenating the hash with our empty string in the variable triangle. Now let's print the triangle. So let's run our program. And there you go. We have the triangle. In this tutorial, I am going to talk to you guys about two-dimensional lists in Python. Two-dimensional lists are extremely powerful and they have a lot of applications in data science and machine learning. Here is an example. In math, we have a concept called the matrix, which is a rectangular array of numbers. Let me show you. So we have, inside the square brackets, we type 1, 2, 3 and in the next line 4, 5, 6. So we have a rectangular array of numbers. So we have rows and columns. So this is a 2 by 3 matrix in math. We can model this in Python using a two-dimensional list. A two-dimensional list is a list where each item in that list is another list. So we can define a list called companies. Inside this, we'll be having 3 more lists. So in the first list, we have Netflix, YouTube, and Facebook. In the second list, we have Google, Instagram, and Amazon. In the third list, we have Dropbox, Spotify, and Reddit. So as you can see, in a two-dimensional list, each item in our outer list is another list. So how do we access one here? We start with our list and then we add square brackets, companies of 1. This expression returns the inner list. So in this list, let's say we want to access the second item. So companies of 1, and again we add the square brackets and type 1. So if we print this on the terminal, we get Instagram. So using two square brackets, we can access two individual items in our matrix. We can also modify the values using this syntax. So say instead of Reddit, we want Uber. So companies inside the square brackets 2, add another square brackets and type 2 equals Uber. So let's print companies of 2, again add square brackets and 2. So there you go. So here we can also use nested loops to iterate over all the items in the matrix. For row in companies, in the next line, for company in row, print company. So let's run this program. And there you go. We get all the items in our list. In this tutorial, I am going to show you a powerful feature we have in Python called unpacking. So let's define a tuple called days. Monday, Tuesday, Wednesday. Now let's say we want to use these values in a large complex program. So to get these days, we have to write the code like this. Days of 0, and days of 1, and days of 2. Our code is getting a little bit too long. This is just a simple example. But let's say we want to use these values in quite a few places in our program. So a better approach is to get these values and store them in separate variables, like A equals days of 0, B equals days of 1, and C equals days of 2. So instead of using days of 0 or days of 1, we can simply use A or B. But in Python, we have a powerful feature called unpacking. With that, we can achieve the same result with far less code. So we can define our variables A, B, C equals days. So what we have on this line is identical to what we have here. So let me explain how this code works. When the Python interpreter sees this statement, it will get the first item in the tuple and assign it to this variable. And then it will get the second item in the tuple and assign it to the second variable, and so on. So we are unpacking this tuple into these variables. So now if we print A, we can see that A is Monday. Similarly, B is Tuesday, and so on. This is unpacking, and this is not limited to tuples. We can use them with lists as well. So let me change the parentheses to square brackets and now run our program. We can see B is Tuesday. In this tutorial, I'm going to talk to you guys about dictionaries in Python. We use dictionaries in situations where we want to store information that comes as a key value pair. Here is an example. Think of an applicant filling up a form. Now the applicant has a bunch of attributes like name, email, phone number, and so on. Now each of these attributes has a value. For example, name can be Dion Cardoza, email could be dioncardoza123@gmail.com, and phone number could be, for example, 1234. So what we have here is a bunch of key value pairs. What we have here is keys, name, email, and phone, and each key is associated with a value. So this is where we use dictionary. Let me show you how to define a dictionary. So let's start by defining a variable called applicant, and then we add flower brackets. Inside the flower brackets, we define key value pairs. Now here let's type name, and then we add a colon, and here you type the name of the applicant. So for example, let me type Dion Cardoza. Now add a comma. In the next line, let's type male. Now again add colon and type false. Again add a comma. In the next line, let's type phone. Add colon. Let's type 1234567 8. Now here these keys should be unique. Now if we add another key value pair here, male, and set it to true, So we can see that it has highlighted that. So it is not allowed. So let's delete this duplicate. Now here I am using strings, but keys can also be numbers. Now value can be anything. It can be a string, it can be a boolean, it can be a number, it can be a list, anything. Now we can access each value in the dictionary using square brackets. For example, applicant, and inside the square brackets type name. Now let's print this. So the name is Dion Cardoza. So what if we pass a key that doesn't exist? So applicants of gender. So we get a key error. Now if we spell the name with a capital N, we get a key error because we don't have a key with the same characters in the dictionary. Now to get around this, we can use the get method. So applicants.get name. Now if we pass a key that doesn't exist, it doesn't give an error. For example, applicant.key of gender. Now let's print this. It returns none. So if the dictionary doesn't have the key, we can also supply a default value. So applicants.get gender, male. So this is how we can access the value associated with the key in the dictionary. We can also update these values. For example, applicant male equals true. We can also set a new key. Applicant age equals 30. So here's an exercise for you. Remember, we had been to a shop to buy some fruits. Now imagine you are the owner of the shop and you want to calculate the total price of the fruits. So I want you to write a program to display the total price in words. For example, if the price is 15, you should display 15. So let's start by defining a variable called total underscore price. We will use this variable to store the result of the input. So input total price. So next let's define a variable called word, and this is going to be our dictionary. So here we are going to assign key value pairs of numbers and words like this 1:1. So here key is a number and value is a word. Similarly, we will do this for 2, 3, 4, 5, 6, 7, 8 and 9. In the next line, type price underscore in underscore words and set it to an empty string. Now let's type a for loop. For price in total price in words plus equals word.get. And inside the parenthesis, we'll pass price. Now add a space and add a plus sign. And now add an empty string. In the next line, let's print the price in words. So print price in words. So now let's run this program. Total price. Let's enter 15. Now press enter. So we get 15. Here is the solution from the last tutorial where we created a program that can display numbers in words. Now so far we have been writing our code in app.py, but as our programs grow we need a better way to organize our code. We need to break our code into smaller, more readable and more manageable chunks called functions. So a function is a container for a few lines of code that can perform a certain task. For example, you have learned about functions like print, input that perform a specific task. So when we build our program, we need to break our code into small reusable chunks which we call functions. And that is what I am going to show you in this tutorial. So let's write a simple program. Let's define a variable called a. A equals input. Hello, what is your name? In the next line, let's print. Here we use a formatted string. Hey, comma, in the flower brackets a. Welcome to the Python course. Now let's say we are going to need these two lines in other programs. So we can put them in a function that we can reuse. So we start typing def. That is a reserved keyword in Python and is short for define. When the Python interpreter sees this, it knows that we are defining a function. And now we have to give a name to our function. Let's say hello underscore user. Here you should use lowercase letters and separate multiple words using an underscore. After that we need to add parenthesis followed by a colon. So now I am going to put these two lines inside our function. So just press tab. So now these two lines are part of our hello user function. And these two lines will be executed whenever we call our function. So now let's go out of our function and call our function hello underscore user followed by parenthesis. So let me explain how this code is executed. So when Python runs this program, it doesn't execute these two lines because these are inside the function of our program. So they will only get executed if we call this function. If we don't call this function, these two lines will not get executed. So when we are calling our function here, Python interpreter jumps here and executes these two lines. So note that the order of function matters. So here we have called the function after we have defined it. If we call this function before defining it, you will see that we get this error. So we always define our functions first and then we call them. Here is the function we created in the last tutorial. In this tutorial, I am going to show you how to take the input here instead of asking it in the function. So here inside this parenthesis, we can add parameters. So these parameters are the placeholders for receiving information. So we can pass the name parameter here and ask the name of the user while calling the function. So the name we pass here will work as a local variable that we define inside our function. So let's run this program and we get, hey Dion Cardoza, welcome to the Python course. So now let's call the function again and pass a different name. Let's say James Robert. Imagine if we didn't have this function, we had to repeat this line twice. So this is the benefit of the function. We can take a few lines of code and put it inside the function. So let's run our program. Hey Dion Cardoza, welcome to the Python course, and we get, hey James Robert, welcome to the Python course. Now note that when we have a parameter, we have to pass some value to that parameter. Now if we remove Dion Cardoza, we get a type error, missing one positional argument. The argument in programming is the value that we pass to the function. So here, Dion Cardoza is the argument that we pass to the name parameter. We can also define multiple parameters. So let's change this to first name and last name. Now here in the print function, we have to change this to first name and last name. So while calling the functions, we have to give it two values, Dion and Cardoza. So let's run this program. So we get, hey Dion Cardoza, welcome to the Python course. In the last tutorial, you learned that whenever we define parameters, we should always supply values. Otherwise, we get an error. Let's look at that one more time. So I'm going to delete Cardoza and only pass Dion. Run our program and we get this message. Hello user, missing one required positional argument. So the arguments we have here, like Dion and Cardoza, we refer to these as positional arguments, which means their position or order matters. In other words, the first argument we add here is the value for the first parameter, and the second argument we add here is the value for the second parameter. So if we change their position or order, we get a different result. Let's pass Cardoza first and then Dion. So run this program, and instead of getting hey Dion Cardoza, we get hey Cardoza Dion. So that is the reason we refer to these arguments as positional arguments. In Python, we also have the keyword arguments for which the position doesn't matter. So here, let's say we want to pass Dion as the value for the first name parameter. So we can simply specify first name equals Dion. So what we have here is called the keyword argument. So the parameter followed by its value is called a keyword argument. So we can use a similar argument for Cardoza. So last name equals Cardoza. Now we don't need to use keyword arguments always. We can just pass positional arguments. But in cases when you're passing numbers as arguments, it is better to use keyword arguments because it is easier for someone else to understand. For example, cost 10, 20, 30. Now for a person who doesn't know what these numbers are, it might be difficult for the person to understand. So we can use cost, apples equals 10, oranges equals 20, and mangoes equals 30. So this is what I want you to take away. For the most part, use positional arguments, But if you are passing numerical values, it is better to use keyword arguments for better readability. Now, one more thing you need to know about these arguments is that these always come after the positional argument. Let me show you what I mean. Hello user, first name equals Dion and then Cardoza. So here we can see this red underline because we are passing a keyword argument and then the positional argument. So if you are mixing the positional and keyword arguments, you should always use the positional arguments first and then the keyword arguments. So let's remove the keyword argument. So Dion is a positional argument and let's make Cardoza a keyword argument. So now we can see we don't have the red underline here. So far you have learned to create functions and send them information using the parameters. In this tutorial I am going to show you how to create functions that return values. So this is particularly useful if you are creating a function that does some mathematical calculations and you want to return the result. So let's define a function def and let's call it sum. So def sum of a comma b. In the next line type return a plus b. So our function has one line of code, but you can also have a function that has tens of lines of code. So this return statement is very valuable. With this we return values to the callers of our function. So now if we call our function and give it the value 2 and 5, this will return a value just like the input function. Our sum function returns a value. We can simply get it and store it in total. Total equals sum of 2 and 5. Now let's print the total. There you go, the result is 7. So we can also simply pass this function directly into the print function and we don't need this variable. Now what happens if you don't pass the return statement in our function? Let's remove this return statement and print the result on the terminal. So we get none. So when the Python interpreter interprets this code, it will first call this function. So here we calculate the sum of these numbers and then print it on the terminal. Now by default all functions return the value none. So if you don't have a return statement here, by default Python statement returns none. So it is an object that represents the absence of a value. So here we didn't have a return statement. So Python returned none. So by default all functions in Python return none. And you can change that by using the return statement. Here is the code for the number to word converter program that we wrote earlier. Now your exercise is to reorganize this code into a function. I want you to extract a function from this code. Now this algorithm for converting numbers to words can be used in a lot of applications. We can use it in system management applications or any other application. So we don't want to write this code again and again. So out of all the code we have from line 1 to line 17, lines 2 to 16 belong to our algorithm. So you should put this in a separate function. So why aren't we taking the input from the function? This is because we can take input in different forms. Like now we are taking it from the terminal. In the future we may take it from the graphical user interface. Similarly, the last line should not also be included in the function because in this program we are printing the output, but in another program we may send this output as a mail. So go ahead and reorganize this code into a function. So let's start by defining a function. Let's call our function price converter and pass total price as an argument. From this program, let's take the code from line 2 to line 16 and paste it into our function. Now press enter. Here we type return price in words. In the next line type total underscore price. Here we are taking the input from the user. Input total price. Now let's print the total price in words. Print price converter total price. Now let's run our program. Total price. Let's give it 25. So we get 2, 5. In this tutorial, I will talk to you guys about classes in Python. Classes are extremely important in programming. We use classes to define new types. So far, you have learned about basic types in Python like strings, numbers, and booleans. These are the basic and simple types in Python. We also learned about the complex types like lists and dictionaries. When these types are extremely useful, they cannot be used to model complex concepts. So we can use classes to define new types to model real concepts. In this tutorial, I am going to show you how to define a new type called applicant. Back to our program, let's define a variable names and let's set it to James, John and Robert. Now here, when we type names, we get access to methods and functions which we can access. So now we will be creating an object called applicant, and this is going to have methods like name and age. Let me show you how to do this. So we start by defining the class keyword and then give our class a name. So note I have used a capital letter here. We use lowercase letters for functions and variables and separate them using underscores. But while defining classes, we use capital letters and we don't use an underscore to separate multiple words. Instead, we capitalize the first letter of every word. Here, we add a colon. So inside this block, we can define our program. So def name, add parenthesis and add a colon. Now inside the parenthesis, add a self keyword. We will get back to this later. Now for this method, let's print name. So here, let's define another function called age. So add the keyword self and in the next line print age. So with this class we defined a new type and with this type we can create new object. So an object is the instance of a class. A class simply defines a blueprint or template for creating an object, but object is the actual instance based on the blueprint. So to create an object we type the name of our class and call it like a function. Applicant followed by parenthesis. So we can store that object in a variable called applicant1. So applicant1 equals applicant. Now when we use the dot operator, we can see that we have these two methods, name and age. Now let's call the name method of our applicant object and run our program. So you can see name is printed on the terminal. Apart from the method, these objects can also have attributes, and these are like the variables that belong to a particular object. Hereafter we define applicant1 dot. So here applicant1 dot a equals Dion. Applicant1 dot b equals James. So let's print applicant1 dot a. So let's run our program. So the name is Dion. Now we can create another object. Let's call it applicant2. Applicant2 equals applicant. Now this object is completely different from the first object. Now if we print applicant2.a, look, we get an attribute error. So each object is different instance of our point class. So here we can define a value. Applicant2.a equals 35. Print applicant2.a. So we can see the age is 35. You have learned how to create new types using classes. So now there is a tiny problem in this implementation. We can't create an applicant object without A or B. Applicant equals applicant. Print applicant.a. Let's run this program. We get an attribute error. To solve this problem, we use a constructor. So a constructor is a function that gets called at the time of creating an object. So here, while creating this object, we need to pass values for A and B. Let's say applicant equals applicant, Dion and James. So this object will have its A and B initialized. So how do we do this? We need a special method in this class called constructor. So we define a new function underscore underscore init underscore underscore. So it stands for initializing. So this is the function that gets called when we create a new point object. Now after self we need to add two parameters A and B. And in the body we need to read the values passed here and use them to initialize our objects. So when we pass John and James, these arguments will be used for A and B. To initialize these objects, we write code like this. Self.a equals A and self.b equals B. So the self that you see here is the reference to the current object. So when we create a new point object, self references that in the memory. Earlier, we used applicant1.a equals Dion. Now what we have in the constructor is the same. We are using self to reference the current object. So using this init method, we can initialize our objects, and we refer to this method as a constructor. This method is used to construct or create an object. So let's run our program, and there you go. A is Dion. You can also change these values. So before printing, applicant1 equals applicant Dion and James. In the next line, applicant1.a equals John. Print applicant1.a and run our program. So A is updated. So here is an exercise for you. I want you to define a new type called the applicant. This applicant should have three attributes: applicant ID, applicant name, and applicant phone, as well as a show method to display the values of these attributes on the terminal. So this is a very easy exercise, so spend a few minutes and you will see my solution next. So let's start with our class keyword, class applicant. Add a colon. Now we define our function, def underscore underscore init underscore underscore. Here we pass self and then we pass three arguments, applicant ID, applicant name, and applicant phone. Add a colon. In the next line, self.applicant_id equals applicant ID, self.applicant name equals applicant name, self.applicant phone equals applicant phone. Now we define another function to display the values on the terminal. So def show and inside the parenthesis self. Add a colon. In the next line, print applicant ID, comma self.applicant_id. In the next line, applicant name, self.applicant name. In the next line, print applicant phone, comma self.applicant phone. Now let's create the objects. Applicant1 equals applicant 1, comma Dion, comma 1 2 3 4 5 6 7 8. Now let's create our second object. Applicant2 applicant 2, comma John, comma 09876543. Now let's display this on the terminal. So applicant1.show. In the next line, applicant2.show. Let's run this program. And there you go. In this tutorial, I am going to talk to you guys about inheritance in Python. Inheritance is the mechanism of reusing code. So let me show you how it works. So we have an employee class with a simple name method that simply prints a name message on the terminal. Class employee. In the next line, let's define a function, def name, and inside the parenthesis pass self. Print name. Now let's say in a real program, instead of one line of code, here we have tens of lines of code. Now say in the future we want to define another class called student, and we are going to also have the name method there. So we have to again repeat our program. Class student, def name self, print name. Now say you find some problem in this naming method. So you have to come and change in all duplicate functions. So how can we solve this problem? So we have different approaches. So one approach which is easier to understand for beginners is inheritance. Now here is how it works. Now we define a new class called applicant and then move the name method right there. And then we have the employee and student class inherit from their parent. So on the top we define a new class. Let's call it applicant. Now let's move this code inside here. Now we want employee class to inherit this method from the applicant class. So after the class name, we put parenthesis and type the name of the parent class like this, employee, and inside the parenthesis applicant. With this, the employee class will inherit all the methods defined in the applicant class. So there is a little problem here. Now if you see here, you can see a little red underline. This is because Python doesn't like an empty class. Here our employee class is empty. So we need to add the method specific to employees. Or just to make Python happy, we can use the pass statement. That means nothing. So we are telling Python to skip this line. Now let's do the same for student class. So student, applicant, and then we use the pass statement here. So here we can create an employee or student object. So employee1 equals employee, and then employee1. And when we call the dot object, we have the name method that we defined in the applicant class. So employee1.name. Now let's run this program. There you go. We see the name message. Now here we can add methods specific to the employee class. For example, here let's define a function called qualification, and inside the parenthesis pass self. In the next line, simply print qualification. So when we type employee1 dot, we have the two methods, one which we inherited and the qualification method we just defined in the employee class. So we can similarly do this for the student class. So we can define a method called grade, def grade, and inside the parenthesis pass self. Now just simply print grade. So when we create a student object, we have these two methods, name and grade. So these are the basics of inheritance in Python. In this tutorial, I'm going to talk to you guys about modules in Python. A module in Python is a file with some Python code, and we use modules to organize our code into different files. So instead of writing all our code in app.py, we want to break our code into separate files. We call each of these files as a module. With this, not only our code is better organized and structured, but we will also have the ability to reuse our code. So in this file, I have written two functions for calculating the sum and difference of any two numbers. We can take these functions and put them in separate module called calculator, and we can import that into any module that needs these functions. So let's create a new file and name it calculator.py. And now let's cut our code from app.py and paste it in calculator.py. Now we want to import our calculator module into our app module, and that is easy. On the top, type. We write import calculator without the extension. So now this calculator is an object. So we can use the dot operator to access its members. So currently we have these two functions inside our module. So we can call any of these functions and pass the values and then run our program. Import calculator. In the next line, print sum of 5 and 2. So that is 7. So now there is another syntax for importing modules. Now instead of importing the whole module, we can import specific functions from that module. Here is how it works. We type out from calculator import. So here we can grab one of these functions, say difference, and then we can directly call this function like how we define in this file. Difference 10, 4. So when we import a function from our module, we can call that without prefixing the module name. So here is what we should take away. We use modules to better organize our code. Instead of writing all the code in single file, we break our code into different files. So here is an exercise for you. Earlier in this course, we had an exercise for finding the longest string in the list. Now here is what I want you to do. This code here has no organization. We wrote all this code in app.py. So I want you to write a function. Call it find_mlen. This function should take a list and return the longest string in that list. After you do this, put this in a separate module called importance.py. Then import the importance module into the current module and call this function. So spend a couple of minutes on this exercise. You will see my solution next. Now here's the code from that exercise. So we will put this code into a function. Let's call the function find_mlen, and let's pass companies as the argument. Now let's cut this code and paste it in importance.py. Back to app.py, let's import importance. Now we define a variable to store the result. Let's call this variable result. Result equals importance.find_mlen, and inside the parenthesis type companies. In the next line, let's print the result. So print result. Let's run our program. So we get Microsoft. In this tutorial, we are going to learn about packages in Python. Packages are another way to organize our code. Now we have only 3 files for 3 modules in our project. But a real project can contain hundreds or even thousands of modules. We don't want to add all those modules here because over time this directory will get overloaded with so many files. So a better approach is to organize modules inside a package. So a package is a container for multiple modules. In other words, it is a directory or a folder. So in a project, we can add a new directory. And in that directory, we can add all the modules. So in this tutorial, I am going to show you how to create packages in Python. So now, let's add a directory and name it fruit store. So now this directory is empty. So let's create a new file in this directory and name it __init__.py. When Python sees this file with this name, it treats this directory as a package. So let's create a new module here called total. Inside this module, we will define a function called total_price. So def total_price. In the next line, let's simply print total price. Back to app.py, there are 2 ways to import this module. You can import the entire module or you can import one of its functions or classes. First, we are going to import the entire module. Import fruitstore.total. So we have to prefix the module name with its package. So to access any of the functions of this module, we have to type out fruitstore.total. So let's go ahead and run our program. So we see this message printed on the terminal. So with the approach, you have to prefix everything with fruitstore.total. So when working with packages, we use the second approach, using the from statement. So from fruitstore.total import total_price. Now we don't have to prefix this function with fruitstore.total. We can call it multiple times in this module. So our code is a little bit shorter. But what if you want to use multiple functions in this module? We can either import them here like total_price, total_tax, or we can import the entire module and access all the classes and functions in that module. So to import the entire module, we type from fruitstore import total. So now this total module is an object. So we can access all the classes and functions defined here using the dot operator. So total_price. So we can start from the package and import a specific module, or we can start with the package.module and import a specific function. So this was the basics of using packages in Python. In this tutorial, I am going to talk to you guys about built-in modules in Python. So Python comes with a standard library that contains several modules for common tasks like working with date and time, generating random values, and so on. There are so many modules already built into Python, and that means there is already lots of functionality we can use. We don't have to code all of that from scratch. So let me show you where you can find the standard library. So open up your browser and search for Python 3 module index. On this page you can see here the Python 3 module index. So let's go ahead. So these are all the modules built into Python. For example, we have the calculator module. We have modules for sending emails. There are so many modules here. In this tutorial, I am going to show you how to use module for generating random values. So on the top, we import the random module. As random is a built-in module, we don't need to have a file here. So now we have this object random, so we can use the dot operator to access its methods. So one method which is very useful here is the random method. Every time we call this, it generates a value between 0 to 1. So here we can do a for loop. Let's say for I in range of 3, random. So let's print the result. There you go. So we can see that we generate a new random value between 0 to 1 in each iteration. So what if we want a whole number as a random value? So we have another method here called randint. So we pass arguments here. Let's say 1, 10. So randint 1, 10. Run our program one more time. And there you go. We also have another method for randomly picking an item from the list. So let's say we have a list of fruits and we want to pick a random fruit. Let me show you how to do that. Fruits equals apple, mango, pineapple, orange, and cherry. Now we can call random.choice and inside the parenthesis we pass fruit. This method randomly picks an item from this list. So we can store the result in fruit and print it on the terminal. Let's run our program. So there you go. So here is an exercise for you. I want you to build a number guessing game. Using the random module, generate random numbers and then accept the input from the user. Give them 3 chances. If the number guessed by them is correct, print congratulations, you won. And if the number they guessed is greater than the number, display the guess is too high. Else, display the guess is too low. This is a little challenging program, but it is very interesting one. So spend some time and then come back and continue watching. So first, let's start by importing the random module. So import random. In the next line, let's define a variable called number. We will use this variable to generate random numbers. So number equals random.randint 1, 9. Now we will create a variable to store the chances. Initially, we will set it to 0. In the next line, let's write a while loop. While chances less than 3. So here, we are giving the user 3 chances to guess. So in the next line, let's define a variable called guess. This will store the input from the user. So input, guess a number between 1 and 9. Now we want the input as integer. So let's convert this to integer. So int of input. In the next line, let's write an if statement. So if yes equals number, print congratulations, you won. Now we want to come out of here. So let's type break. In the next line, let's write a condition to check if the guess is less than the number. So elif guess less than the number, print your guess was too low. Guess a number higher than, then add a comma and type guess. In the next line, let's add else. Else print your guess was too high. Guess a number lower than, comma, guess. In the next line, let's increment chances. If you don't do this, our chances will always remain 0 and this loop will run continuously. In the next line, if not chances less than 3, print you lose. The number is number. So let's run this program. Guess a number between 1 and 9. Let's enter 5. Your guess was too high. Guess a number lower than 5. Let's enter 3. Your guess was too high. Guess a number lower than 3. Now let's enter 1. Your guess was too low. You lose. The number is 2. Even though the Python library is very much comprehensive and has so many modules for common tasks, it is not complete by any means. That's why we have this library called Python Package Index. And in this library, you can find thousands of packages for doing awesome things. These are the packages that people have built as a part of their projects, then published in this directory for other people to use. And that's why we have a fantastic community in Python. There are so many Python developers out there, and there are thousands of packages in front of us to reuse in our programs. Let's say you want to get information from Wikipedia in your programs. You don't have to build this from scratch. You can simply come to pypi.org and search for Wikipedia. As you can see, there are so many packages and projects that give you this personality. Not all the packages are perfect. Some of them also have bugs. But if you look around, I'm pretty sure about any kind of functionality you could imagine, there is a good, reliable, and well documented package. Now in this tutorial, I am going to show you how to install packages from pypi.org. So here on pypi.org, let's search for Wolfram Alpha. So let's search for this package, and there you go. On the top you can see pip install Wolfram Alpha. So this is the command we need to type in our command window to install this program. So just execute this command I show you. Pip install Wolfram Alpha. Make sure to spell everything properly. So pip is the tool that comes with Python installation. So we use it to install or uninstall packages. So here we are using pip to install this package. Now press enter. So we can import this package or its modules just like the built-in modules in Python or the modules that we have in our project. In this tutorial, I am going to show you how to work with directories in Python. So here you can see the OS module documentation. So the OS module is the module that provides us with several useful methods that we can use to work with files and directories. So you can see here how this module works. And you can also see all kinds of examples. There is so much documentation that you can see it on your own. But let me just quickly show you a few examples to help you get started. So back to our program, let's start by importing the OS module. So import OS. Now to get the current working directory in Python, we can use the get current working directory method of the OS module. So we type print os.getcwd. So now let's run our program. And there you go, you can see the current working directory. So the current working directory is the directory that you are currently working in. Now imagine you want to create a new directory to store your files. For that, you can use the make directory method. So os.mkdir. Here you pass the name of the directory. So let me pass test. Let's run our program. Now we can see here that our new directory is created with the name test. So this method helps you to create new directories in Python. Now let's say you wanted the name of this directory to be test1 and not test. So how do we change it? This is very simple. You just type os.rename. So this renaming method can be used to change the name of an existing directory or a file. So os.rename, and here we pass two values. First we pass the name of the directory or the file whose name we want to change, and then we pass the name of the new directory. So os.rename test, test1. Now let's run our program. There you go, the name of our directory is changed. Now let's say you want to change the current working directory. For that, we simply type os.change directory and then pass the name of the directory in which we want to work. Like this, os.chdir, and inside the parenthesis type test1. So let's run our program, and there you go, our current working directory is changed. So another method I am going to show you is the list directory method. This method is very useful when you are working on large programs. So you want to know all the files and directories you are working with. So you can use the list directory method. Let me show you how. So here we type os.listdir. Now if you don't pass any value here, it will show you all the files in the current folder. So let's run our program, and there you go. Now let's pass the directory here and let's run our program once again. There you go. So one last method I am going to show you can be used to delete files and directories. So if you want to remove a file, then simply type os.remove and then pass the name of the file. So let's run our program. Now we can see that our file is deleted. Now let's delete this directory here. So to do this, we simply type os.rmdir and then pass the name of the directory. So let's run our program, and there you go, our directory is removed. Now note that this method works only for empty directories. So you can use this OS module to do so many useful things like create, rename and delete directories and files. In this tutorial, I am going to teach you guys how to handle errors in your Python program. So let's start by writing a small program to get the user's year of birth from the terminal. So we define a variable called birth year and set it to int of input year of birth. In the next line, just simply print birth year. Now let's run our program. Now let's enter a year. Press enter. Now the exit code of our program is 0. Exit code 0 means our program terminated successfully and has no errors. But what if we run this program one more time and instead of entering a numerical value, we enter something like A, B, C? So we get a value error with this message. Basically, what this is telling us is that this string does not contain a valid whole number that can be converted into an integer. Now the exit code of our program is 1, means our program crashed. So we should always anticipate these situations. We don't want to let our entire program crash just because the user entered an invalid value. So instead of having this program crash, we should handle this crash and print a proper error message. And that is what I'm going to show you in this tutorial. So before going any further, look at the type of error here. We get a value error. Now how can we handle these errors? In Python, we have a constructor called try except. We use that to handle errors. Let me show you how it works. On the top, we type try colon. So I'm going to move these two lines inside our try block. So now these two lines are a part of our try block. After the try block, we type except. And then we add the type of error that our program may encounter. That is value error. Then we add a colon. And in this block, we can define what should happen if our program encounters an error of type value error. In this case, we want to print a proper error message. So print invalid value. So with this try and except, we are telling Python, hey, go ahead and try running these two lines of code. If you encounter an error of type value error, instead of crashing the program, print this error message on the terminal. So this is how this works. Now more accurately, in programming terms, we refer to this kind of error as an exception. So an exception is a kind of error that crashes our program. So if the user enters an invalid value, then this line of code on line 2 will raise an exception, and on this line we will catch it and print this error message, so our program will no longer crash. Let me show you. So let's go ahead and run this program. Let's say 2004. Everything works like before. Let's run this program and enter ABC. So we get this error message, invalid value. And we can also handle different kinds of error or exceptions. For example, let me write a program here to calculate the remainder. So try colon. In the next line, let's define a variable a to store the first number. So a equals int of input, enter the first number. In the next line, let's define a variable b to store the second number. So b equals int of input, enter the second number. So in the next line, let's define a variable to store the remainder. Remainder equals a mod b. In the next line, let's print the remainder. Print remainder. Now here we have to write an except block. Except value error. Print invalid value. So here let's pass some values and run our program. So everything is working fine. Let's run our program again. And then let's pass the value for b as 0. So we get a 0 division error. To solve this problem, we can write another except 0 division error. In the next line, simply print denominator cannot be 0. Now let's run our program. Now let's pass the value for b as 0. So we get this message, denominator cannot be 0. So we use try and except block to handle exceptions that are raised in our programs. As a programmer, you should always anticipate these exceptions and handle them properly. Hey, I just wanted to make a quick announcement. In case you haven't seen my website yet, head over to dioncardoza.com. It is my coding school where you can find plenty of courses. I will soon be publishing a Python course that goes way beyond this course on YouTube. So that brings us to the end of this video. I hope you learned a lot. Please support my hard work by liking this video and sharing it with others. And also be sure to subscribe to my channel for more tutorials like this. Thank you so much for watching and I hope to see you soon.